15th of December 2021, yeah, equivalent to 10 Jamadil Awal 1443. Our class start at 8 a.m. and we are going to talk about the continuation of the last lecture on fluctuation of speed and energy. Okay, I already explained to you the basic principle of what is the meaning of the topic itself, what is the keywords, what are the used in the engineering perspective about the turning fluctuation of speed energy toward turning moment diagram, or sometimes we call crank effort diagram. And we had also been talking about the principle and also what else, the application on the engineering perspective. Yeah. So as for today, we're going to look for the continuation of the lecture. So I'm going to share with you the slide on PowerPoint, PDF. Yeah. Okay. And you also been provided the notes with you, so you can check your notes on your own. So if you can catch my lecture, please do find material info in your material. Also, you have book with you. You can turn to page starting from page 100, 206 onwards. Yeah. So as for today, I'm going to talk about this one, the principle of input torque and also resisting torque. The application or the special application on this topic will be on the internal combustion engine, or we call it the ICE, and also motor. As you all know that internal combustion engine basically drive automobile vehicles. Doesn't matter whether it's car, motorcycle, or whatever it is. At least it's powered by engines. Yeah? And the other one is a motor, which will drive the machine. So many machine in engineering world. Yeah, for example, lathe machine, milling machine. What you have is basically lathe machine. This is the automated lathe machine. Yeah. I go further. The next one. If you remember in my last lecture, I did mention about there are four, cases you have to understand. One will be the cases will be regarding the input torque and also the resistant torque. So the input torque is basically coming from this one, yeah. As I mentioned earlier, this one is coming from the internal combustion engine, and the resistant torque is let me check. Yes, I have to pen with me. Yeah, and the resistant torque is coming from, so this is the input torque, this one, yeah, the input torque. We're going to talk about input torque here. Get a darker one. And this one will be the resisting torque. Resisting torque. So the input torque will be the internal combustion engine, or you just can call it engine. And the other one is basically coming from the motor. And I did mention about the internal combustion engine. I did ask in class day before yesterday, yeah, in our last lecture. I did mention about the input torque can varies, and it can also be constant. So do the resistance. So the resistance can also varies and also constant. And I did explain about the engine is typically giving you the variable input torque to engage the gear 1, gear 2, gear 3, gear 4, and 5, so on and so forth, to basically make the vehicle move. So as you engaging gears, so the torque became varies. So there is a fluctuating of input torque, isn't it? But if you look at the resistance, or perhaps coming from the vehicle, as I mentioned earlier, the resistance of the vehicle coming from the capacity of the engine itself. One, the other one is what, the bearing or whatever devices or whatever compartment in the engine, which is always there, giving you friction. The other one is the level of the road, for example, so also giving you friction. So the friction is always constant. So this one giving you constant resistance. Okay, when you come to motor here, motor is always giving you constant torque. This one, constant torque. Except unless you're using the, what do you call it, yeah, step motor, or what do you call it, regular motor, that you can regulate the torque. This one is not. We are going to talk about the very conventional motor, which is a very constant input torque, input torque, input, yeah. And when the motor drive the machine, for example, so the machine will give you resistance. So what are the resistance for the machine? Typically, the the material to be cut, isn't it? The level of the space surface, whether you cut it thick or not thick, thin or thick. So that what else? Type of material, for example. So these are varies. The machine give you variable. Okay, so remember this one, yeah. Engine always give you what? Variable torque. This one, variable torque, input torque, yeah. But motor will always give you constant torque, input torque. And the car or the vehicle is always giving you what? Constant resistant torque or output torque, because this one input, this one output, and but the machine is always giving you variable torque. So to talk about this one, I'm going to share with you the next slide. This one. As you understand that one, so I'm going to share with you the slide. So of course, yeah, when you want to do analysis, you need to know, isn't it? You need to know the graph. Remember I did mention about the graph? Is a turning moment diagram. So we are going to focusing on the graph now. The graph will provide you all the parameter in terms of what is the input torque, what is the input torque coming from engine or motor, whether the input torque constant or not constant, as well as the resistant torque coming from the vehicle and the machine, and which part a vehicle or machine give you constant and variable torque. So it will be presented by this one. So it is much easier when people present to you in graph rather than in the actual model, isn't it? So look at here, isn't it? So you have what? This one is the input torque, this one is the resisting torque. So look at here, you have constant torque. Can you see my slide, class? Hello? Okay, thank you, Ko. This one, look at here, constant torque. Look at here, constant torque. This is, of course, this is turning moment diagram. Turning moment diagram when you have a graph with Newton meter of the torque in y-axis and you have the radian in x-axis. So whatever you have in the graph will be representing the area under the curve, which will be telling you about work done or perhaps energy. So look at here. The line is one show you what? The line will show you constant. As the line show you constant, it always called T-min. Remember that when the line constant, it always called T-min. Doesn't matter if it belong to input torque or resisting torque. So this one is coming from the input torque. Okay, look at here, power source. Yeah, you look at this one in terms of power source. It can also be in other words is input. Look at here, the next one. You have constant resisting, so both constant. Okay, so this one, if you have both give you constant, you have constant input, you also have constant resisting, so you don't need, so no need to control. No need to control. You don't have to control this one. What is the reason for controlling when you have both are giving you constant? Okay, look at the next one, figure 5.6. You have the input torque constant. Input torque constant. Again, we are referring to turning diagram. Constant. And we call it as T-min from the input. The other one you have what? You have variable torque, which varies and keep varies. This one is variable resisting torque. Look at here. When you have input torque constant and when you have the variable or the resisting torque it varies, you found this one coming from motor. Remember motor drive what? Drive machine. But remember, yeah, these two graphs is basically represented by one graph only. Remember that. Okay, remember that. These two graphs will be overlapping or superimposed, which presented to you only by one graph. How the graph look like, we're going to go for that later on. Okay, next. Okay, the next one is what you have is the variable torque now. The variable torque keep fluctuating, fluctuating over a period of time, isn't it? So this one and the other one, when they drive something, for example, it seems that the resistant torque is constant, so we have Tmin. So this one you have what? You have internal combustion engine, or just call it an engine. Engine drives something, vehicle, for example, a generator, for example, so on and so forth. Okay, so remember that when you have the torque providing you the variable torque, and you found that the resistive torque is constant, it coming from the engine drives something. And finally, the fourth one, you have the variable, torque is generated by the power source or the inputs. And at the same time, the resistance also provide you variable torque. So this one you don't have to, no need control, no need to be control. Okay, so out of four category of cases in flywheel, or perhaps in the fluctuation spin energy, we can, this one need to control, need to be controlled. This one also same thing, need to be controlled. To ensure that the system that you run or that operating will be in the steady condition. Okay, so out of four, we are going to talk only two here. So now let me go to the next one. Put it here. In the first one, the internal combustion engine. Okay, the internal combustion engine. Everyone know about internal combustion engine. So our concern is here, maximum fluctuation of energy. And we're going to look for maximum fluctuation speed as well as flywheel. This is the flywheel that connected to the engine. And this is the graph that provided earlier in the case 2 or in the case 1, if I'm not mistaken, or case 4, if I'm not mistaken. It doesn't matter which case we are dealing with, as long as you understand that this type of power source or source, giving you, providing you the variable input torque, whereas it will run or drive the constant resisting torque. Okay, so this is the coming from motor drive machine. Look at here, this one, this one is very very clear about it. If you meet, or if you see the machine, for example, very old machine, you know that this one is the flywheel. The flywheel is easy to see, isn't it? It's not covered by anything. And this one is the motor. Of course, the motor will be connected by belting system. And you have another one, this one. Then it will run the system. This one could be a forging, punching hole machine, yeah. So you have a motor. So which motor will drive in constant torque? This provide you a graph here, constant torque from the motor. This one now is motor. And while the machine here, this is the machine, you provide me, or it required you, or providing you the resisting torque from this one coming from the machine. What is the control parameter? Yeah, here is because due to the material, for example, the hardest one is always very difficult to make operation, for example, or to make hole, for example, or to make a finishing line, for example. How big is the hole here, for example, you're talking about drilling machine, and how thick will be your cut, depth of cut, for example, you're talking about milling machine, so on and so forth. And toward that, what will be the type of machine, for example, whether you're talking about material of mild steel or stainless steel or wooden, for example. So this kind of material will give you different resisting torque, yeah. Okay, so we are going to move on now on internal combustion engine. Look at here, this one also been discussed earlier. I already mentioned about, remember, if you have as such graph, even though the graph is not as what you have here, the actual thing, when you, look at the analyzer, yeah, you can simplify the graph from what you have in analyzer to be as such, because this graph is what basically representing by what? By sine and cos, isn't it? So sine and cos, so you can easily calculate what will be the area under the curve. So this is the area under the curve that we concern. This one, and easily calculated. If you have as such, it will be calculated by using integration. For example, if you have the equation of the line, of course the equation of the line will be provided later. So to make it more easier, you will provide the graph in terms of straight line graph. It's much easier. You don't have any equation. You just use the the equation coming from the rectangle, square, or perhaps the triangle equation, to look at the area under the curve. So, and we have the T mean here. When you have the maximum torque and you have minimum torque, you have a T mean here. And any area above T mean we consider as positive. So this area now is positive area. And the rest will give you negative. They need something. For example, suction here. The suction activity need what? They need fuel, for example, and also need what else? Place to chamber, for example, to suck or to induce the fuel, for example. Then you need compression. How does compression look like? For example, you need a plunger or place to compress both fuels, and also air. Then working, you need ignition. You need a spark plug, for example, to give you spark. Then it will burn something, isn't it? Then only you give you exhaust. This one, of course, will give you power. Working, sometimes we call it power. So this is the only area give you positive work done. The rest will need something to run the system. Even though you know this one is a for activity, this one will be run very fast, and a very split seconds, a blink of eye, for example. Yeah. So any graph or any area below T mean, this one be T mean, yeah, is negative. Remember, yeah, is it measured from the T mean? It's measured from T mean. It's not measured from the what? From the origin. No, it measured from the T mean. So this is why you need T mean here. Okay, so that is one. So as I mentioned earlier, the graph is not stand by itself. The graph will provide you only two graphs. Then you have to split the graph by two. For example, this one is the original graph. This one, yeah, this is the original graph. Yeah. You split into two. This is the input torque, which keep varies. This one will be the resisting torque, isn't it? Resisting torque is constant. So the area under the curve here is basically representing what? If you can put it here, work done, for example, yeah. This one is T theta coming from resistance. The other one, this one, if you can calculate every graph here, every area here, and here, and also here, and here, and here, so that will give you T theta also, but inputs. Okay, in our life, there is always equilibrium. So in any possibility of equation, you need equilibrium condition. So this equation will be what? Equate by this one, input equal to output. So you will have T theta by input equal to T theta by resistance. Or some call this one input and output. It doesn't matter as long as you know that this one is coming from the conservation of energy. So a big principle here we have been doing is we are going to look for conservation of energy. Conservation of energy. Wrong spelling. Conservation. SCRVA. This one is conservation. So it's wrong spelling. Yeah. Sometimes I'm not. My word and my writing is not synchronized. So conservation of energy. What is the conservation? Meaning that input and output is always in equilibrium condition. Or you can put this one, yeah, equal to 0, for example. So there is no lack of input, there is no excess of output, for example. So if you found that input and output not equal, so you cannot apply in the principle of flywheel. So you need to this one to basically apply the principle or to design the flywheel, energy in flywheel, for example. Okay. So the next one, this one now, our aims now is to define what are the energy or what is the energy, okay, in the system. Okay, class, are you following me or not, class? Hello? Or do I talk to myself here. Yes, Lee. Thank you, Lee. Yeah. Okay, now, assuming that you've been provided a such graph, okay, they provide you a such graph which have a straight line here, then it will be fluctuating from A to G. And you know that as the input graph will keep fluctuating, coming for the internal combustion engine. And assuming that you provide this one engine torque, and the straight line here is the mean resistance torque, and we call this T mean. We call this one T mean. Okay, now let's assume again, you have been given here A is the area under the curve, B, C, D, E, and also F. You've been given, or perhaps you can calculate. If this graph is represented by straight line, it's easy to be calculated, isn't it? Okay, now, it will be fluctuating, as I mentioned earlier, must be below and above T mean. It is not fluctuating below and above origin, no. But fluctuating below and above T mean. So as you have this one, we already mentioned earlier, so any graph above T mean is positive, below T mean is negative. Okay, so then keep thinking that this one is positive, this one will be negative, so on and so forth. Okay, now, then you are doing the energy analysis. This is what we call energy analysis. Okay, what is the function, or what is the aim, or what is the objective of energy analysis? To define the energy required by the system or generated by the system. Okay, so that is the energy analysis. For example, here, you know that the engine torque will be crossing the mean resistance torque, or T mean. I call it T mean only. Yeah. So you have point A, point B, point C, D, the capital one, A, B, C, D, E, up to G here. And we are doing the energy, remember the conservation of energy, telling us that input equal to the output. So we start here. We start A equal to U. A equal to U. Then B here, U plus A, U plus A. You can put yes and A equal to E, doesn't matter. We put it U now. Okay, U plus A, U plus A. Then you go further, which is at C, you have U plus A minus B. You go further, plus C. You go further, minus D. You go further, plus E. And then you go further, minus F. And as you reach G here, it must be equal to U. You understand now? Oh, in numerical, it must be equal to 0. So if this is not 0, what does it mean? It simply means that, what does it mean if this is not 0? So if, for example, yeah, if this one not 0, so what does this mean? Can anyone tell me? Up to here, your calculation, if you have a numerical later on, it is not 0. So what does it mean? Could anyone answer this one? If you don't want to answer this one, I want to give you this one. So yes, energy is not conserved. Yes, thank you, Lee. Yes, thank you. Okay, yeah. So if you found this one is not 0, so energy is not conserved. So your calculation here, along line from A to G is basically not correct. Okay, so that is easy to detect. Very simple to detect. Yeah, so you have to understand that when you calculated and find that it's not equal to 0, so your calculation along the line A to G is not correct. So you have to check what will be the parameter. Of course, you need to check the area here. Okay, so now you move on and on. Then our aims now is to define what will be the E max and E min, right? So of course we don't have a numerical here. So we're going to assume that this is my assumption, yeah. This is theory only. I'm going to assume that the maximum energy at B here, I'm going to assume that the minimum energy at E here, which I basically do not know unless I know what be the numerical or the numbers and the value. So you have E max minus by E min is equal to, we call this one beta E. What is beta E? You have to understand that if it is E, sorry, you are basically learn this one in your static and dynamic. If you're the E max in E min, you have delta E is equal to E2 minus by E1, is it? But here, what you calculated here only on statics, or there is no changes in in the energy or perhaps in the area and the curve with respect to time. And this one with respect to time we have beta here. It's called this beta will keep changing, equal to E2 minus E1 if E2 and E1 is maximum and minimum respectively. So if the equation asking you about what would be the coefficient, for example, you have beta of beta equal to E max, E min divided by E. This E is E min, M-E-A-N. This one is min. It's two different terms, even though I pronounce sometimes basically about the same. Okay. Okay. So as you calculated along the line, you know that will be the maximum minimum. You find that out. You find out this one and this one. Then you have as this one. This one is the delta E. B minus C plus D, which we do not know at the moment, because we don't have any motive here. We are going to look for the theoretical part only. So as you go further here, let me go about this one. Okay, as you go further here, I will share with you, which will give you more. Do you have the blank screen with you? My working template? Yes, Lee. Okay, now we already know that beta E just now. We already know that the beta E just now is calculated by E max and E min. And we do not know this one is based on what? This one is based on graph of what? Turning moment diagram, which we have no idea at all what will be the velocity, isn't it? We do not know what it is. What we do know here, after you calculate this one, you have a number here, and of course number will be in terms of joules, or perhaps Newton meter. This one is not over here, equal Newton meter. So our aims now is to define the continuation of the graph in theoretical. Okay, so now energy generated is equal to what? Kinetic energy. Why? Because we are talking about flywheel. Remember flywheel? Flywheels always give you what? Kinetic energy. And you know well the kinetic energy is given by the equation of equal to half mv squared. Correct. And this equation is not cannot be used here as excuse me as this is the linear one. So we have to convert this one from linear to become angular. So but you have the velocity is equal to omega cross r. You put it here, you found that the Ke now is equal to half m keep maintained. So you have the omega square r square. So supposing let I is equal to m r square, where you found that the r equal to k. Remember the equation I equal to mk square, where k is basically radius of gyration. So we assume this one, we introduce this one to the equation. Then finally, we have the kinetic energy. It will give you half I omega square. Okay, this is one equation. Okay. On the other hand, you know that as the system keep running or operating in certain speed, you know that the omega mean, as I mentioned earlier, mean is equal to omega max plus the omega mean divided by 2. Isn't it? So no doubt about it, isn't it? So the other one, I would like to introduce to you alpha, which equal to the this one is the coefficient of the fluctuation of speed. This one is coefficient of fluctuation of speeds. Just now, beta is coefficient of fluctuation of energy. This one is alpha. Beta, we already have the equation just now, E max minus E min divided by E. And for the alpha here, we introduce, because this one, because we're dealing with speed here, so this must be omega max minus by omega mean divided by omega mean. Okay. So any question up to here? Any question? Any question, class? Hello? Any question? Yes, thank you, Ko. Yeah. So now you have this one. Remember, you have this one, the equation, and you also have this one, isn't it? So, but as we agreed just now, the del this one, yeah, the beta E is basically E max by the E min. So you have E now. If E is equal to, yeah, if E equal to half I omega square, so you will have beta E is equal to E max minus by E min. So you will have here is equal to half I. This one is omega max max square minus by half I omega min square. Isn't it? So you can simplify the equation because the equation is not very difficult. This one put in factor minus by omega min square. And this one in mathematics, is my mathematics is correct, is this one can also be in the form of omega max minus by omega min divided by this one, yeah. Oh, sorry, it's not divided. Stop. This one multiply by omega max plus omega min. Isn't it? Yes or no? Yes or no? Correct or not? So if you go back to the equation that we have earlier, this one can also be in the form of alpha omega min is equal to omega max minus omega min, isn't it? This one also the same thing. If you simplify the equation, this one can also in the form of omega min 2 is equal to omega 2 minus omega 1. If you simplify the equation. So if you put the equation in here, you found that you have half I. This one will be in terms of well, just now you have 2 omega 2 alpha here, yeah, 2 alpha just now. Oops, 2 alpha. It's not 2 alpha. It's alpha. It's alpha. It's alpha. This one be omega max minus by omega min. And we have another one, 2 omega min. This one is, you will have omega not correct. It's not correct, class. It is not correct. Let me clear this one. I supposed to simplify. Now I'm going to put everything in the equation. It's not correct, huh? So it's supposed to be half is correct. This one is I is correct. This one already put this one omega max minus by omega min multiplied by omega max plus the omega min. So you have equal to half. This one is I. And you have this one alpha. Isn't it? Alpha this now. Yeah. Alpha omega min. Alpha omega min. Put in the alpha omega min. This one is here you have 2 omega min. So we have 2 omega min. So this one is 2. So this one and this one cancel. So basically you have beta E is equal to what? I alpha omega min power of 2. Any question up to that? So this is the only equation we are going to use in both application. Of course, you have to manipulate the equation later on, yeah? Okay. So if I put a from graph, remember, from graph and theory, so you'll be getting a very long equation here. A max minus E min equal to I alpha omega min power of 2. And remember, yeah, this one always from what? From what? Turning moment diagram, which provide you basically from energy analysis. Energy analysis. Energy analysis. Okay, this one coming from theory. Okay, so these are thing that you have to understand. One coming from the turning moment diagram, area under the curve, basically. The other one is coming what you've been derived from the principle of the, what do you call it, the energy, which is coming from the kinetic energy. Okay. Of course, yeah, you can manipulate the equation in such a way that you want to look for, some other parameter. For example, let's say we want to design the flywheel. Designing flywheel is basically to find the parameter of the flywheel. The parameter that we concern is basically the radius, the thickness, and also sometimes is the what do you call it, mass, for example. But basically these two, radius and thickness. Let us again assume that we have a solid one, solid. This one be the radius, this one be the thickness. I'm sorry, my drawing is not as good as you, I'm sorry about the inconsistent on the line. Even my handwriting is bad, Okay, if you want to comment on my lecture, please do not comment about the handwriting and also my drawing. That is why I provide you a very good notes video so that you can catch it from your notes. Let's say we want to design the flywheel to find the parameter of the flywheel I for that. So therefore, from what we have earlier just now, beta E is equal to E max minus E min. We use this equation again, equal to I alpha omega min square. So I now is equal to, you will have here, let's say we put it here, E max by E min, E max by E min divided by, this one be alpha omega min square. Of course, from here, alpha is equal to, we have already know that max minus by min divided by min. And we already have the omega min here, the omega min here is basically, we have the omega max plus omega min divided by 2. Okay, so now if you have this one, but you need this one already calculated. Okay, this one, let me put another color, so this one already calculated. This one already calculated. You get from the graph, find this one from graph. What graph we're dealing with is turning moment diagram. Of course, we do the energy. This one calculated. You want to know what I, isn't it? I equal to whatever you have. Equal to, let's say you are dealing with the the solid, for solid. I'll put it there for solid, for example, for solid flywheel. For solid flywheel, spud. Where is spud? No, it's not spud. For solid flywheel, put it here for solid flywheel. You have what? I is equal to half m arc square. Is equal to what you have earlier, E max, isn't it? From x, this one is x. Put it here, kilogram meter square. Okay, you just focusing on this one. Focus on this one. So you have I equal to half m r square. But m now is equal to rho v. This is but m equal to rho v. Rho is what? Density of the material. For example, for the mine steel, you will have 8,500 kilogram per meter cube divided by the v. V will be the volume. It's not velocity, yeah, the volume. So you can expand the equation, it becoming equal to rho. This one be E N T. Again, this one is the area multiplied by the thickness, isn't it? You can also expand this one to become what? Rho maintain as so. This one is area will become pi r square by t. Right? So you put it here is equal to half. M will be in terms of rho. This one will be pi r square. This one will be t. And we have another r square. So if you look at the equation now, you cannot solve the equation. This one known. Known. Or calculated. This one calculated or known. Yeah? Calculated. So you will have this one equal to half. This one given. Pi will remain as pi. This one r power of 4 t. You cannot solve this one because you have two unknown. So equation will provide one ratio of thickness, radius and thickness. Radius and thickness. For example, radius is equal to 4 times of thickness. Or in other words, it can also be put in terms of RT equal to 4. This one or this one. So you put it in here. Okay, so you will have here is equal to half rho pi. This one will be r power of 4. T will be here equal to 1. We have r. T will be, let's say you want to look for r, for example, yeah. T equal to what? R by 4. R by 4. Isn't it? So what you have here, you will have 1 upon 8 rho pi r power of pi. And this one you have a numbers here. This one your number or value. So you'll be getting then you get this one, you'll be getting put it here. Do you understand me or not? So this is how do you use the equation and you design the parameter for the flywheel. Is that clear? Anyone? Hello? Yes, thank you, cool. So perhaps in other equation, yeah, they provide you in other equation, if R no and T known, perhaps you have to select the materials, isn't it? So you have I equal to half rho. This one just now what? Put it there from the very beginning, yeah. We have rho, put it there R, pi r power of 40. Pi r power of 40. So this one all known. This one known. This one is constant parameter. This one known. So you have the rho in kilogram per meter cube. Then they provide you listing of material. For example, mild steel, MILD, mild steel is equal to 8,500 kilogram per meter cube. So you will have to look for stainless steel, for example, so on and so forth. So this is some other form of equation. For example, if they want you to look for or to design what are the material to be used in, in the system, for example. Okay. The most important thing now is the turning moment diagram. Okay, now let me go. Any question before we move to the next one? Here, any question? No? Any question? Can I hear your voice, class? Any question? Or you cannot on your speaker or your mic? Okay, thank you. Yeah, so now we're going to move to this one. This one I also provide you, alhamdulillah, all the example typically coming from the what do you call it, the coefficient of energy. Remember just now, coefficient of fluctuation of energy here. Yeah, this one, yeah, the coefficient of fluctuation of energy. So you have this one, beta just now. And I also provide, if you go further on in your notes here, you'll be getting, or you can see this one, the other one, coefficient of fluctuation of speeds, this one. Okay, so this one is coefficient of fluctuation of speed. So you will look into what type of machine here, so on and so forth. Of course, when you buy a machine, yeah, very big machine, you've been provided the manufacturer or the vendor will provide you all the specification. So in the specification book, you found all this kind of information. Yeah. Let me move to the next one before we go to the tutorial. Examples. Yeah. I'm going to go further on to look at the significance of what do you call it? The significance of here, this one. Significance of this one, yeah. The significance of the graph you have earlier, which is coming from this graph, this one. And we're going to use another graph representing this one. For example, yeah, from all the curve graph here, we're going to give you as such this one. This one, for example. Okay, this one also from coming from the internal combustion engine. And this one look like very much easier compared to the earlier one, because you can calculate this one by using a simple equation from the rectangle, triangle, or perhaps a square, isn't it? So this one you can do on your own. Yeah? But the only principle what you have to is here, any area above the mean is always considered positive. This is the most important thing. I will be explaining to you, or perhaps sharing with you, what if you suddenly you take this one wrongly, instead of negative, instead of positive, you put a negative. I'm going to share with you an example later on. Okay. This one you can do on your own. Basically, this one is exactly the same as what we did earlier. So let us now move to the motor drive machine. This one is motor drive machine. I already shown you here just now. Okay, again, as I mentioned earlier, the graph provided here is only a single graph. But then you need to draw, you need to draw what? The mean line. Doesn't matter whether you are talking about internal combustion engine or you've been talking about motor drive machine. This is your part. You need to draw the mean line. So you must have the capability to what? To read the graph. Reading the graph is not reading the graph is not reading the numbers. Yeah, reading the graph is to check which part is varies and which part is constant. Which part mean that whether the power source varies or constant, whether the resistance varies or constant. Okay. This one, for example. Okay. Then you put when you've been given here, then you construct this one. You will have a line of the mean. So this area representing all what energy from the power source, or you're talking motor will be motor here. So the motor provide you the graph represented by this one. You calculate this one, it give you t theta by the motor. You can put this one instead of motor, can put this one inputs. This one is the graph presented here is given by the machine, for example. So every under the graph, this one will be given or be provided by the machine. So this one can also, this one output, can also put this one in inputs, in input in the general word, yeah. So this one for the machine or output, this one for the motor or the input. So these two graphs must be equal in terms of magnitudes or value. It's not equal into the physical, yeah, in terms of the magnitudes. If you be getting this one 100, this one must be 100, but in the in different presented graph. So when you do this one, you overlapping the two graphs, you be getting the T mean, this T mean. Okay, then only as you get the T mean, this is the most crucial things. When you get T mean, look at your class. When you get T mean, so this one is T mean now. Look at it very careful. This one is T mean. So along the line, you put it A. This one will be, remember, the intersection point between the line of the T mean and the line of the resistance torque. You have D and also E. Okay. Then you will have a new graph here. The new graph will be below T mean, above T mean, below T mean again, and above T mean if the graph ended at this one. So this is the new graph. And this one for the energy analysis. Okay, because we are doing the problem coming from the motor which drive machine. So any area above T mean will be considered as negative, and any area below T mean will consider as positive. And you look at this one, compare from what you have earlier, is basically one opposite from what you have in the internal combustion engine. Okay, this one is most of student, basically forget about this a positive and negative part. Very important, this one. Once you put it wrongly, you'll be getting 0 for this particular parts. Of course, you'll be getting the same result. I'll be showing you again, inshallah, in the example later on. So as you found this one, so let's put it here for example. Yeah, I'm giving you example. Put it here A for example, as I gave you earlier. This one B, this one C, D. So when you doing the energy analysis, it seems that you have A is equal to energy at A equal to U, energy at this one A, energy at B is equal to U plus A. Right. Energy at C equal to U plus A minus B. On and keep going here. U plus A minus B, excuse me, minus C, plus C. Last but not least, at A here, you find that U plus A minus B plus C, plus this one, yeah, minus D, sorry, minus D must be equal to U. Then you see that energy is conserved. Okay. Then for along the line from A to B, C, then you start selecting where be the maximum and minimum as what we did earlier. So the only difference here from what you have in the internal combustion engine is this one. So this is the only thing that make you different from what you have in internal combustion engine. The rest will be exactly the same. Do you understand me or not? This one for motor, drive machine. This one for the internal combustion engine. Remember, this one will be positive. This one will be negative. Is that clear? Hello? Yes, Ko. Thank you, Ko. Yeah. Okay. If there's no question, I go further. This one is what I've been talking earlier just now about the equilibrium of the T motor and the T main, and the T machine. Basically, we call it as conservation of energy. This one is conservation of energy. Okay. This one I also mentioned earlier. No point I'm doing this one again. Yeah, you have this one in your notes, and I already explained about things that you have in you. So this one again, remember, This one I already mentioned earlier. This one already done earlier to define what be the parameter. This is the size for flywheel. We already done earlier. Then we're going to do the example. So before we do the example, I would like to share with you this one, what we call it, the highlighted notes. Look at here. Look at here. First, the equation. The general equation, it's not Jensen, general equation, is the general equation. Is basically what? Is beta E is equal to I alpha omega mean. So, or can also be in the form of E max minus by E. The E max minus by E mean. This one, yeah. This one from TMD, turning moment. And you have to look at this one from the energy analysis. Okay, otherwise you cannot find the Emax limit. And you need to know this one. Energy must conserve. Energy is conserved. Is the principle. Okay, so after you've done this one, the whole thing will be easy. So you know well that the alpha now is equal to the omega max minus by omega mean divided by the omega mean. Or can also be in the form of n max minus by n mean divided by n mean. On the other hand, you have the alpha here, you also have the omega. Omega is omega mean is equal to omega max plus omega mean divided by, or can also be in the form n max minus or plus n mean divided by n. Astaghfirullah. This one is divided by 2. So I here, I can be calculated I equal to half mr square if solid this solid disk, or you will have I equal to mk square if design this one sometimes we call flywheel. Okay, look at here. Sometime typically in motor drive machine you have beta E equal to I alpha omega mean power of 2. So this I is equal to I system. Typically in motor drive machine, this I is basically I system. What is I system? Is the I system is equal to, we go back to here. Now you tell me, what is the I system? You can answer this one, then I will go further and I explain to you how to use this I. Otherwise, I will leave it at that and you have to check on your own. You tell me, what can you see from this machine here? You can speak up, you can open, you can on your mic, or perhaps you can talk something, or you can write something. I prefer you, you talk or you speak through mics. Anyone? If you don't want to answer this one, I'll just leave it at that. You have to check on your own what is the I system to you. Anyone? Can you on your mic or not class?
Maybe it's rotating stuff.
So now I system, what is the I system? Yes, Stan. What do you understand by times I system looking from this one?
The rotating part, the thing.
Yes, thank you. Yeah, who's online? That one, Tan? Is it Tan? Yes, thank you, Tan. So now, I system is basically I coming from the motor and I coming from whatever you have plus the I flywheel. So you have I system is the I motor. Of course, inside the motor, you have all rotating parts. So this one is rotating part plus I. This one is I flywheel. I flywheel. Understand, yeah? So look at this one. Typically, this one for what? For motor drive machine. But if you go back to the internal combustion engine, look at the internal combustion engine. Look at the internal combustion engine. Where are you, internal combustion engine? I'm talking about the principle, yeah? Look at the internal combustion engine. You know that your beta E is equal to I alpha omega mean square. Look at the I. You only has what? You only have flywheel. So this I system is equal to I flywheel only. You understand me or not? So you have to read the equation very carefully. Yeah, sometimes they provide so many things, but you need to know this I is basically the I system because we have been talking about the whole system. Okay, same thing here. The comprising the whole thing that will be plus the I flywheel. So this is our concern basically. This is our concern. Okay, so I'm going to, so we move to where stop just example. Okay, now any question before we proceed? Any question? Okay. If Ahmad not respond, I will remove Ahmad. Ahmad. No.
Uh,
Yeah, well,
Doctor,
yes.
can you show the last working
Which one?
for the working template, the doctor working template?
Oh, working template. Okay, this one. Is it the one?
Yes, this is the one. Can doctor scroll up a bit? Yeah. Thank you, doctor.
Okay. Okay, yeah. So we are basically just not talking about what is I. Sometimes I is I system, sometimes is I flywheel. So depending on the question, sometimes, but I'm saying this one typically is meaning that in practical, this I is the I system. They provide so many parameters. For the I coming for the internal combustion engine is basically for the I flywheel. Okay, but sometimes in lecture just want to check your understanding. Yeah, they put you so many I even in internal combustion engine, but it is not correct basically. Yeah. Okay. We are going to move. We are going to move to this one. Example. Example. Where are you? Example. I'm going to move to example. This one. This is very typical example in couple of years ago in the exam in the test. Yeah. Okay, what you have here, you can turn to page 208, 218. For those who are not have book with you, I also provide the solution with you. But if you don't have book, meaning that the information you have in your hand is so little, yeah, compared to those who are buying the book. You have to, in learning, you have to sometimes you have to, to have sacrifice buying books. Okay, now what you have here is the example number 1 on page 218. Okay, the turning moment diagram of for a petrol engine is drawn to following scale as shown. Look at the turning moment diagram, 1 millimeter, 5 Newton meter, so on and so forth. This is the what you call factor. 1 millimeter is equal to 5 Newton meter is the factor. This one is the factor. And the turning moment diagram repeat. Look at that. Repeat itself every half revolution of the engine, and the area above and below. Look at that. T mean below the mean turning moment line. T mean, this one is mean that is T mean 295 up to 70. They provide you as such. They've been calculated for you now. So it is make your life easier. You don't have to do anything. So 295 up to 70. And the rotating part here, look at it. The rotating part of the equivalent to mass of is 40 and the radius of gyration is 150. So this one provide you I equal to mk square because you have the radius of gyration. Okay, complete. This one you can calculate. And then, so determine the coefficient of fluctuation of speed when the engine running at 500 rpm. You want to define coefficient of fluctuation of speed. What does it mean? You want to calculate alpha. One part. The other part will be maximum and minimum speed of the engine. So what will be the maximum and minimum speed of the engine? Basically, it's omega max and omega min. This is very typical question, if they provide you as such. Okay. So let's go to the solution. You have the solution with you. Either you can refer your book or you can refer from your notes here. First, what you have is from this line here. You have to you have to check T mean, and this one be from the input top Paris. Or if you will understand, this one is from the engine. Correct? So whatever you have here, this one you keep what? Check the intersection point, the cross line between the two line of T mean and also the engine line. So you put it A, B, until whatever you have here, until it reaches the last one. So the next one you have here. Okay, because we are dealing with internal combustion engine, so you have to decide. So you pick up here as positive area and negative area or energy. So this one all positive, this one are all negative. So then you do energy analysis. This is what you call as energy analysis. But of course, yeah, in test you cannot do this one. You have to start with what? This one is just solution. So in test or in exam, you have to start with number one, procedure. Look at here. Procedure of solving problem. Number one, you start with what? General equation. Then you know which part you're going to look for. What is the general equation? You have beta A equal to E max minus by E min is equal to, we have I alpha omega min square. So start with this, then you know where to go. Otherwise, you do not know which part you are going to deal with first. So the equation asks you to define what just now is to define what will be alpha, isn't it? Equal to, correct? You can ask to define alpha. Look at here. What is the coefficient of fluctuation of speed is alpha basically. So alpha is equal to, if you can manipulate the equation, is basically beta A is equal to, this one is I omega min power of 2, or you have E max minus by E min divided by this one I alpha, I omega min power of 2. Then you know, oh, this one, it must be dealing with what? Energy analysis, this one. Otherwise, you cannot do anything about it, isn't it? You cannot complete the equation. So this one must come in from the turning moment diagram. From the turning moment diagram, I must do the energy analysis. From the energy analysis, then I must what? Look for the Emax and Emin. So this is the idea. So from this one, I must follow the principle that energy is conserved. Then if you do this one correctly, this one I is not a big deal, mk square. The omega min also not big deal, equal to omega min square is equal to 2 pi n by 60. So the most important thing is this one. So then only, okay, now start with turning moment diagram. I'm going to plot the turning moment diagram as what we have here. Then I'm going to do the energy analysis. Okay, now let's do together the energy analysis. So this is how you go about it before you start anything. Yeah, don't just simply do the energy analysis without knowing what they're going to do the next one. Yeah. So now if this is the energy analysis, then you believe that this one is positive, this one is negative. Then you start thinking this one is positive, this one is negative. Apply what? Energy conservation, saying that this one is U. Now you have, okay, the total energy at A equal to U. The next one is energy at B. U what? Plus 95. You do not know the negative or positive yet. You don't know this one. You do not know yet. You have to run through the whole exercise. Then you go to C here. C will be U plus 295 minus 85. You will have this one. Plus, then you minus, you get this one. Then you go further up to D. D here, U plus minus, then you plus 40. This one, look at here, plus 40, plus 40. So you have as such. You go further up to here, you minus by 340 below, minus by 340, you have as such. We do not know positive, negative, maximum, minimum yet. Correct? Until you go the whole exercise. F now, plus 690 plus 690. Correct? We have another one. And finally at G here, you found that 270 minus 270 becomes 0. So then it is correct because energy is conserved. Then you can do the next one. If you found this one is not correct, yeah, you have U plus something. Then you have to check all your calculation. Go back to your calculation and do again one more time to check this one to ensure this one becoming 0. I always say to the student that if you don't get this one, you get 0. If the energy density doesn't give you 0, you get 0 for this. For this, for this part of the calculation. So then as you get 0 this one, then only you check along the line where will be the maximum and where will be the minimum. So if I look at here, so I'll be looking at 295. This one, look at 2 plus 295. And also I'll be looking at negative 690. So this one is my maximum, this one is my minimum. Then you put in equation. This equation, remember, beta E is E max minus by E min. You put on the numbers, you will be getting 985. Don't worry about this one, yeah. This one, because what you'll be getting here is 985. It's basically in millimeters square. We don't want this one because beta is in units of Newton meter or perhaps in joules. So that is why again they provide you, the equation provide you what? The factor. 1 millimeter is equal to 5 Newton meter. So you have to multiply with the factor here. Multiply by the factor, so factor will be this one. What you have is 1 millimeter is equal to 5 Newton meter. You also have 1 degree is equal to what just now? 1 degree, 1 degree, 1 millimeter equal to 1 degree. You also have here 1 millimeter equal to 1 degree. So this one is 1 millimeter equal to 1 degree. 1 millimeter equal to 1 degree. So convert this one into radian. Convert this one into radian. So you'll be getting this one. This one is basically, we have what? We have 5 pi. Oh, sorry, it's not 5 pi, yeah? It's pi only. Multiply by 2 pi multiplied by 360. I already simplified the equation. So this one, cancel, you'll be getting this one. Okay? So we'll be getting 86 joules. An equation. That will make your life very easy because the next one is not very difficult. So the next one, what you have here, you have, okay, I put in all the value here. Look at here. Alpha, beta E calculated to be 86. This one I calculated, mk squared just now. And in fact, the omega mean also calculated. Then you have put it power 2. You do this one, you'll be getting as such. Okay. Okay, now I'm going to explain this one. how to use the equation. Remember alpha. Okay, go back to here. Okay, tell me what is the alpha equation just now? If you don't want to answer this one, I'm not going to share with you how do we get this one suddenly divided by 2 divided by 2. You have to answer and cooperate with me. What is the alpha just now? Could anyone speak up? Anyone?
N max minus N min divided by W min.
It's not W omega, yeah?
Oh, sorry.
It's not W, it's omega, okay? Okay, now. Omega max minus omega min divided by omega mean. It is correct. Huh? So now, if you can configure the arrangement, excuse me, this one is omega max, this one is the omega mean, this one is the omega mean. So the alpha is basically from the maximum to minimum divided this one. So if alpha is equal to 0. What just now? Is 0.035. 0.035. So many points. 0.035. It simply means that, so this one you must have what? 0.035 divided by 2. You have this one also 0.035 divided by 2. Correct or not? And this one will give you positive. This one will give you negative. Okay, if you put this one n maximum, this one you can put this one n minimum. This one will be your n min. It is the same. So if you can go back to here, you found this one. Look at here, the max n plus half n. This one n is n min, yeah, n min. This one you have the n min. So look at here, this one, the top one and the bottom one. So you will have the equation here. Okay, if you can also simplify the equation to be one, yeah, can also simplify the equation to be, okay, let it simplify n max equal to n min plus this one alpha divided by 2. This one is n min. Put it in negative, put it here min. Easy one, only one equation rather than you have two equations. Then 1 plus and minus. So you'll be getting the result of what you have here. So, okay, now tell me, what would be the margin of this, engine? The margin, the speed margin. What would be the speed margin of the engine? Anyone? Anyone? You don't want to answer this one? I leave it to check this one. What is speed margin? You don't want to answer. Okay, you find yourself what is speed margin. Yeah. So the next thing will be, the next question is indicate or show where this maximum and minimum occurs. This one is occurs. Okay, so to indicate or to show, yeah, you have to go back to the graph. Go back to the graph. You found just now, you want to check, isn't it? You want to find just now, okay, the maximum will be fall at, the maximum will fall at E, the minimum will fall, the minimum will fall at E, the maximum will fall at B. So you found that you will have as such. So this one is the maximum, this one be the minimum for both energy and also speeds. Okay, so now I'm going to do this, the next one. Look at here. Avoid doing this one. Do you have this one in your note? I believe you have this one in your notes, yeah? Okay, look at very careful this one. Avoid doing this one, yeah? Okay. As I mentioned earlier, this part of calculation bring you more mark compared to others because this is the heart of the solution. If you fail to understand this one and you get this one wrong, yeah, if the whole mark carry 20 marks, this one sometimes called 8 mark. So you'll be deducted by 8 mark if the rest of the calculation or the rest of the solution will be correct. Okay, now, so even then it's depend on the lecturer who are going to mark your work. So to minimize your deduction of marks, so do this one, yeah. Avoid doing this one. Look at here. So you know that this one is positive. Are you still with me, class? How many of you in my class? Let me check. I got with me 40, yeah, 40 of you in my class. Yes, Marcela. Thank you, Marcela. Okay, this is the correct one, positive and negative. You do sometimes wrongly. Putting here because you are fall asleep in my class, or perhaps you are the other side, I'm here, you are not focusing my class, you are doing something else while listening the lecture, you are not, what do you call it, participating in the class. So instead of putting positive, you're putting negative here. So negative and positive, isn't it? So this one is not correct, but you fail to follow the class, focusing in class, so you are doing this one, yeah. So now look at here. So you're doing this one correctly. Then you put, okay, energy at A equal to U, correct. This one energy at this one negative, negative instead of positive. You do not know whether it's maximum and minimum yet at the moment. So you keep doing the whole calculation up to here. You take positive, isn't it? Then here is negative. You put it here as positive. This one is basically negative. To the rest, you'll still be getting 0 here. So remember, even though you're selecting the wrong here, notation or sign, positive, negative, you'll be getting the same result. But I will put here as WC. What does WC tell us? It's a wrong concept. You'll be getting 0 for that part of your calculation. Then you start collecting, okay, I'm going to collect my X and my minimum and maximum. Okay, I'm going to select my minimum and maximum. I'll be getting, okay, this one is negative 295. This one is negative 270. This one, I believe, minimum. The rest is 690, 350. Okay, this one is my maximum. Then I put it here together, maximum and minimum. I get the same result. Correct, same result. 985 millimeter square, and I just put the what call it just now, the factor. You also be getting the same result. As you put the factor, you'll be getting same result, and you'll be getting this one. The whole thing will be the same result. The only thing that you failed is this one. If this carry 8 mark, you'll be getting minus 8 mark. So out of 20, you now have 12 by 20. If the whole thing correct. If the whole thing is not correct, it will be more deduction happens. Yeah. So to avoid this one, please make sure that you'll be getting you'll be getting correct sign or notation for each application on internal combustion engine and also a motor drive machine. Okay, is that clear, class? Is that clear? You don't want to talk, you don't want to write, okay, never mind. There is one when people, I think a couple of you asking, yes, Tan, thank you, Tan. Couple of you asking about the tutorial in your books, yeah. I'm not going to respond to anyone except when I found that student that respond in class, then I will entertain you. Otherwise, I just keep keep quiet and not responding to your message, huh? No point of responding your message because you are not also responding in my class. Okay, I'm going to share with you another one. So I'm going to share with you if you are running out of time. You know what is running out of time? You are basically running out of time and you want to answer the question. You want to answer the question. I'm going to share with you how to solve this problem by using shortcut way. I call in my class is magic. But it's no magic. Basically, it's a shortcut way. So I'm going to select where will be the shortcut way. This one. I'm going to share with you the shortcut way here. And I need your cooperation to calculate this one. Okay, this one is the shortcut way. This one is the short. And I would like to advise you not to do this one. Not to this one, except you are basically running out of time. You want to, you want to answer the equation, or perhaps you want to double check the equation. It is advisable. It is advisable. If you have ample of time, do this one as normal procedure. The reason is why some lecturer do not basically aware about this calculation. Okay, okay, now listen up very carefully here. You have as such, then you start what? Then you start looking at the maximum and minimum of the area under and below the curve. When you run through, or when you're traveling you're traveling on the line of inputs. Okay, put it this way. This one is minimum. Am I correct or not? 40 is minimum compared to 90. I got something. 1 minute, yeah. My system here. Okay. Okay, look at here. You have 295, we have 40, we have this one. This one is maximum. Look at here. 685. This one is 340. This one is 270. This one is this is all negative, yeah. This is all negative. This one all positive. So this one is the minimum, right? Because this one is positive. This one is negative. Okay, so then you run through. You work out, or you're running, or you run from the 295, approaching minimum and approaching maximum, you stop. Understand me? Okay, approaching minimum, stop it. Stop here. Approaching, you run again, you run again, you run again, you run again. Approaching maximum, you stop. So this point will give you beta E. Okay, that point will give you beta E. Again, I would like to explain again. First, look at the maximum and minimum. Positive, maximum is 960 compared to others. This one all negative. This one is minimum compared to others. Correct? Then you run. You walk from the 0 here along the line. Then you stop while approaching minimum and approaching maximum. You walk here and walk. You find this one 685 is negative, is minimum. You stop with one line. You run again, then you follow the line, then you approaching maximum and stop. And these 2 points will give you beta E. So beta E is equal to, do you understand me or not, class? The shortcut way. Hello? Okay, now beta E is equal to what? Beta is equal to negative 685 plus 40. You have minus 340. What do you have? This one will be 340. This one 35. You have negative 985 millimeter squared. Correct. Then you put here ignore negative. Okay, ignore negative. You have exactly the same result from what you have in the calculation, normal calculation. Is that clear? Hello? Is that clear? So, but please do not do this unless you are running out of time. If you have ample of time, you do the same procedure. If you want to double check, yes. If you want to double check, please do. So the next procedure will be exactly the same. Yeah. So I'm going to go the next one. Example number 2 here. Still talking about internal combustion engine. I plan to finish up this one next weeks on Sunday. We have another 2 hours. Then I'm going to do the internal the motor drive machine. Today I'm going to do all the internal combustion. We still have another couple of minutes before we end. I'm going to do this one very fast. Okay, if you look at very carefully, they're mentioning about during the stroke of engine, a piston of double-acting steam engine, the turning moment have the maximum value of 300. And the turning moment diagram of the engine may be assumed for simplicity. Look at here. Assume for simplicity. There is no such graph of the straight line representing internal combustion engine. This one is being done because it is assumed to be simplification of the actual thing to make you easy to calculate area under the curve, providing the what input torque and also resisting torque. Okay, to be presented as shown in the figure. This one. So based on the turning moment given, if the maximum speed they need is not exceed 315, this one is N max, and the minimum is not less than 285. N min, they provide you N max and N min basically to define alpha and also what N min. Right? You have the N min, you have the max min, so we have the alpha. So now determine the following. Following will be the M turning moment. Turning moment. Sorry, it's the T min. Then you have to look at the power. Of course, when you have the power equal to T min omega min. M this one small, M this one representing min. Yeah, the mass moment inertia of I. Then look at for I. If you have as such, again you start with the equation. You start with the equation. Very much aligned equation. General equation is the most important thing to do before you start anything. Okay, now how to define T min? How to define T min? Okay, look at, listen up very careful this one. Listen up very careful. Huh? Okay, T min can define by using what? This one T min, yeah, by using conservation of energy. What is that? That is the T theta of the engine, engine equal to T theta of the resistance. So the T engine, as I mentioned earlier, the T engine is not provided. What they've been provided is one. Can you tell me this graph? Would anyone tell me? Belong to what? Belong to what? Answer me. This graph belong to what? This graph belong to what? Belong to input engine. Thank you, Eng. Yes. So this is graph belong to engine input graph. Okay, now I missed one part. I'm sorry. I missed one part. This one, yeah. Sometimes I also miss one part. So now listen up very careful. Reverse a bit. So the equation of beta E equal to E max. Remember this one, by E min equal to I alpha omega min power of 2. This one, yeah, belong to one cycle operation. I missed this one part of the information. This one is belong to one cycle operation. What does this mean? It means that whatever you have a longer or a graph, yeah, representing a machine, you have to cut the operation of the machine in for one cycle. For example, look at here. For example, for the internal combustion engine, this one T in Newton meter, this one theta in radian. Remember, for internal combustion, you have so many graphs in it. So you have 0, then you have this one, what? 4, 5. This one for what? For one what? For one? For one cycle. The next one you have another one. Next one another one. Okay, so whatever it is, whatever you calculated must be for one cycle operation. Okay, remember that. So if I can go back this one, look at here. If I can go back this one, look at here the graph. I'm going to expand this one, zoom in, so that you can. You can. Minute, yeah. Where are you? Lost. This one, okay. Look at here. As I mentioned earlier, the graphs now must be in one cycle. Must put it in your note. Must be in one cycle operation. Okay, now you tell me, how many cycles do we have here? Anyone tell me, how many cycles do we have here? How many cycles? 2 cycle. Thank you. Yeah, 2 cycle. How do you know? Look at here. It start by. That is why I say that you have the ability to read the graph. Reading the graph is not the reading the numbers here. Reading the graph is to check whether the graph is representing one cycle or more than one cycle. So now 40 straight, shoot down here, straight, shoot up 30, then shoot down again. It will end up at 4 pi, correct? So it will end up at 4 pi for one cycle. The next is start all over again. So this one is 2 cycle. So you have to focus only one cycle. The rest will be ignored. This one will be not part of your calculation. Do you understand me or not? Is that clear? Okay, is that clear? So next time, make sure that you must what? Focusing on one cycle operation only. So now as you know this one, then you take this one. This one just to share with you in the next solution slide, yeah, to share with you. This is the graph coming from the resistance. This one is the graph generated by the engine. Or so these two graphs must be equal. Meaning to say that you have to calculate every point and you have to calculate this one every point. But yet you do not know what the theme. It doesn't matter. You calculate this one, you have the result with you. Have the result with you. So I go back to, can you please go to your notes here? Go back to your book because I'm running out of time. So I'm going to share with you books from what you have in your book so that you can So if I can finish this one, we'll meet again inshallah on Sunday. I'm going to explain it again in detail with all the numbers. Yeah. At the moment, let's focus on how the numbers is, you get the numbers. Yeah. This one, you have a couple of example you can run on your own during your free time, perhaps. You start here. Look at here, this one. So before that, you calculate every single here, every single equation, or even every single, what do you call it? Every single area. You have look at your T mean, T engine is equal to T resistance. This is what I call it as a conservation of energy, equilibrium condition, isn't it? So look at your 40. It doesn't matter how you calculate, yeah. This one area 40. This one is 100 negative. The next one is 300. The whole thing. This one is minus by 20, small portion of here, then equal to T mean, which equal to this one. If I may put it in the blue line. So you have this one, the blue line. So you equate the equation, you'll be getting as such 35. So this is the 30 mean. So the line been cut, yeah, at 35 Newton meter. This one will be at 35 Newton meter as equal to your T mean. Okay, so you answer one question, the first question. The next question is power. Of course, power is T mean calculated omega mean. Omega mean you get from this one. Of course, you have to convert this one from RPM to become radian per second. You have all the equation here. You get this one power. Okay, now you want to define I, isn't it? I will be mass moment of inertia. This one, but you need to have beta E or equal to E max minus by E mean divided by alpha omega mean power of 2. So this one is coming from your energy analysis. Look at the analysis. You have 35 just now. If I can make it a bit bigger, yeah. You have 35 just now. 35. You cut the line at 35. And I'm going to focus on one cycle. And this is the internal combustion engine. What you have is area above Tmin will consider as positive. Below Tmin is equal to negative. Tmin, yeah, is no longer on origin. Tmin. So this one is positive. This one all become negative. This one all become negative. How do you calculate? It's not very difficult. You can do this one on your own, isn't it? So look at here, this one, for example, at point A, at point B, at point C, and also at point D. This one, A will be U, because we are talking about energy conservation. And B here, you can put B here, you can also put B here, doesn't matter. If you put the whole thing, the whole area, it's becoming 75 by and 135. How is it? This one is 75 because 35 and 40 is 75. This one 35 and 100 become 135. You have as such. Then you move on. This one will be 300 minus by 35 multiplied by pi. So you will have as such 210. Isn't it? And then you have as such. And finally, you'll be getting 0. And it is correct. Energy is conserved is correct. Then you do what? Then you do the energy analysis. Then what you have is the maximum. Maximum will be at where? At B. So this one be maximum. This one be this one is minimum. This one be maximum. Then you put in the equation. You will have as such. Then you will have 285. Okay, now at 265, then you have the results. I'm going to explain to you how do we get the how we going to use this shortcut way. Shortcut way. When not today, but when we meet again, I'm going to talk about shortcut way, shortcut way, shortcut way. When you learn with all like lectures, so many shortcut way, will be shared. So the next thing will be you are looking for this one. You be calculated here. So I think we stop at here. So remind me, because we have only 5 minutes. I think if I start with shortcut way, do you have a class after this class? Do you have a class after this? Yes or no? I need about 10 minutes to complete the whole exercise. Okay, you have a class after this. Okay, never mind. So remind me, Tan, the next meeting I'll be explaining to you how basically we are going to solve this one by using shortcut way. I'm not going to interrupt your schedule of joining other classes. Yeah. So we completed the whole thing. When I meet again, inshallah, I'm going to share with you the shortcut way of calculating turning moment diagram. So remind me of the thing that we have here. So shortcut way of calculating turning moment diagram in energy analysis. So next meeting. So any question before we end our session this morning? Any question? No, thank you, Marcella. Thank you very much for your response. Thank you, others, for your response. Those who are not responding, please respond, because if you respond, you know that you understand. Yeah? Otherwise, you keep quiet to yourself, then you find that you are not basically, confident or convenient with the